Hello and welcome back to FPV Reviews. Today we have the SonicModell Binary on the bench. As many of you know, this is a scale or almost scale model of a Tecnam P2006T, which is a twin-engine utility aircraft. And so in this case, it's usually not a good thing when an FPV model or a UAV type model for mapping purposes is based on a scale aircraft, but in this case with the Tecnam it's probably a very good thing, save for a couple of the features. So first of all, let's have a look at the fuselage, and this is to me the really brilliant part of what they've done here. The scale fuselage is nearly ideal for a twin model for mapping in terms of volume, just because the scale airplane was very well designed. Is a very utilitarian platform. Let's look. They've actually managed to take good advantage and good use of a lot of the parts and the features in this in terms of access to the inside of the fuselage. So let's look here. First of all, this top hatch, it's held on by magnets, and it gives an access here to where the flight controller would be mounted. And so the only issue I have with these magnets, they work great, but they will interfere with a compass if you're using one. So as we can see, there's plenty of room in here. You could actually fit a fairly large flight controller in here, like a Pixhawk, but it would kind of be oversized for this model. And we're probably best off leveraging one of the newer full-featured flight controllers, such as the ones from Matek or Omnibus in this aircraft. So we can see here they've left plenty of space to put the wires through for the power that goes to the ESCs from the current sensor. They have the hole where the carbon, I believe this is an 8mm carbon tube, pull-treated carbon tube goes through. And they've included these handy little nuts that go in from the inside like this, and little thumb screws that hold the outer wing sections on. And that actually works quite well. So that's that area. We'll leave this off for a moment. This front deck is also held on by magnets, which works very, very well. These are strong magnets. So if you're not using a compass, or you're not enabling your compass with your flight controller, if you have that disabled, you can definitely keep these magnets. It's very secure. This is a pretty solid piece. It's got a piece of wood pre-glued to it, so it's really stiff. You could mount quite a bit of hardware to this. I'm not thrilled to see it left like this, because I think a lot of people will leave this bare without putting any fairing on it. So this is the fairing they provided, which is clear. But yeah, so that's going to cause quite a bit of aerodynamic drag. But I guess some people will live with that, and those who don't want to live with it will change it. But yeah, this is a pretty solid piece. Also, it provides, it's very big, it provides great access to the inside of the fuselage. This strap actually came pre-installed. I've pulled it out to kind of get a better look around here. But looking into the fuselage, we have pre-glued in a floor inside the fuselage here. All fine and good there. I of course prefer to put things together myself, but a lot of people kind of dread putting the fuselage house together, and this is all put together for you. As you can see, there's some carbon fiber reinforcing here in the sides of the fuselage, and this is really good quality foam. I mean, there's no flex here whatsoever. This is a very tough model, and even up into the nose, it's very tough. And up here in the nose, we see there's this removable part that I assume you would glue in later. They actually have a modular nose gear, steerable nose gear setup that can go in here and can be removed, and then this fairing replaced as well. If you're if in this this belly pan comes with the kit, so you don't have to buy that separately. And there's also a fairing for the main landing gear here, which is great. If you're not using the landing gear, you can put this here. If you are using the landing gear, I noticed they have the kind of a recess here, so you don't have to do a lot of trimming. You can put the fairing back after you put the landing gear plate on with a very minor amount of trimming here. But I'm glad they left that there to seal that gap. As you all probably know, I'm very adamant about aerodynamics and weight, so this is great. These nubs on the side of the fuselage, these on the original aircraft, were to house the landing gear hinges for the retracts. This was totally unnecessary, but they don't really get in the way. They're not going to cause very much drag, so I don't see any point in removing them. It would just make things ugly. On the moving back here, this Payload Bay Hatch, this is, by the way, brilliant. This space back here, it's quite large. As you can see, this is a full-size point and click Lumix type camera, and this would easily fit back here in the payload bay. Now the SonicModell does make some laser cut wood parts to fit different types of cameras, like a GoPro or I think RunCam, that can fit in this area, but you can also make your own. And there's a couple of grooves and like a shelf in here where you could, or a ridge that you could install a shelf that you could make yourself. So lots of room for modification in here. Also, this is fully connected to the battery compartment and the flight controller deck, so no issues there. Right above here, so from the flight controller, you'll probably run a wire up through this hole that's already there, up to this top deck for something like a telemetry radio or an FPV transmitter, depending whether you're doing autonomous mapping or and want to use something like Mavlink to get your telemetry in your data back, or whether you're just using it for FPV. So moving back, this is also kind of brilliant what they've done here. So this is the vertical stabilizer and horizontal stabilizer. The horizontal stabilizer has has a piece of carbon embedded in the stabilizer itself and in the elevator. And I noticed they're using on all the control surfaces these servo horns, which have screws that go through all the way through, capture the carbon rod or the carbon strip, and have a backing plate that they screw into. So that's brilliant. And the way the tail fits together is also quite brilliant. Now there's a groove back here, so this has to go this way. It cannot be upside down, so there's only one way that can go. And this just slides in, and as you can see, it can't twist here. So with that channel that's there, it's locked into place. The only thing it could do is slide out, but there's this tab on the vertical stabilizer, which when you insert it, locks that into place. So also I was quite pleased to see that this is very well fared and fits nice and snug. So it would be possible, if you were to cut out a slice of this, put in a piece of plywood plate, drill a hole in it, or maybe tap some threads in it, and then drill a hole through the fuselage here. You could actually on the bottom here put a backing plate with a screw, something like a machine screw, maybe a nylon one, and you could have a completely removable tail, and that would be just in the right place to hold the vertical tail down in place and snugly down, and that locks the horizontal in as well, so there's nowhere it can go. So this aircraft could be highly portable, It's not very long. So if we were assuming that we were removing the horizontal and vertical tail, let's take a measurement real quick. Yep. 89 centimeters, so just under 90 centimeters is the total fuselage length. So yeah, under 1 meter. So this will fit in a lot of luggage, or you know, not in a very large box. So that's quite good. I really love the fuselage design. Also, I couldn't help but noticing that these 18650 Tesla style batteries will fit no problem crossways in the fuselage, and there's plenty of room to stack them too high inside here. So there's probably quite a few different lithium-ion battery modifications that you could make to this airplane. So that's all good news when it comes to the fuselage. Now let's have a look. Let's set the fuselage aside for a moment here, and the tail, because we've looked at those. They look very good. This vertical tail does not have any carbon reinforcement in it, but it doesn't seem to need it. This is very high quality foam, and it's pretty short, and it's fairly thick, so I'm going to call that fine. I'm very, very happy with that. There's some instructions that come with the model. They have great pictures, so they've done a real good job with the drawings representing things here. So, but this is for absolutely new pilots that are not familiar at all with the aircraft. So if you have any familiarity with other model planes, you pretty much won't need the instructions. There's some plastic blow molded or vacuum formed fairings here. This is for the rear part of the fuselage where the servos go. So you'll cut those out. These are for the wingtips, right and the left. So this is actually two parts. These are for the landing lights. There is a light kit for this model, but you know, I'm pretty much interested in the utility, so I'm not bothering to get that. And this is for the top of the vertical stabilizer for the strobe light. So there's those. There's some stickers along with the big red Sea Rescue stickers that they provide. So stickers. These are part of the wing nacelles. We'll look at that in a minute. We saw the belly pan already. The fuselage landing gear fairing and the hatches. So we'll get those out of the way. And the carbon spar. And let's have a look at the wing. So these wings, if you'll notice, and this is kind of my main complaint with this model. Now this is based off of a scale plane, as we said earlier, so they've pretty much taken and just copied the scale plane without really thinking that much of what could be done or the utility of this model. And this is advertised as a model for aerial surveys, for mapping, specially designed for that. But they've just taken the scale wing and basically copied it, along with these motor nacelles, which on the full-size airplane were meant for a horizontally opposed reciprocating fuel-powered engine. Of course, we're using electric power, so if we look at an electric motor, about the size that this would use, you know, it's really, really unnecessary. So I really wish that they had, you know, made a fairing that was more appropriate for, you know, what was necessary to hide or to fair the electric motor and support it, rather than trying to look scale. It's pretty unnecessary. And you know, the length of the wings here. So You know, if you go to transport this model, you have to transport this fuselage that's nearly 90 centimeters long, which is fine, but each wing, you know, in the transport box could also be much longer. You know, this wing is only 56, maybe 56 and a half centimeters. Looks like close to 57 at the very most. So, you know, that really could have been different. And a lot of people do report that the model flies very fast and is a bit limited in the weight it can carry. Supposedly, the factory test pilots have tested the model to up to 3 kilograms, but I doubt that the landing speeds are reasonable, and I doubt it's floaty at those speeds. Now it does have flaps. I've actually gone ahead on this wing half and cut out the flaps, cut out the edges so the flaps can actuate, and they do look pretty good. Sure, they'll help the overall coefficient of lift a little, and they'll, you know, by increasing the angle of attack on the inboard, they'll prevent the airplane from tip stalling when they're deployed, because the inboard section will stall first and the ailerons will still have control authority because the outer wing section is at a lower angle of attack. So, you know, standard airplane stuff, these flaps, nothing that innovative about them, other than, you know, they're just a standard flap. They're not a slotted flap, they're not split flaps, but it does have them, so I'm sure that will help. I have seen some people who have wanted either more endurance or more capability for carrying payload or batteries, and they've taken and they've created their own wing section. They've added a section here, but what happens is that the motors for the airplane end up really far out from the center line. So if you were ever to lose a motor in flight, or you know, simply have a landing where you dip a wing, either, you know, in the case of losing a motor, you know, the amount of offset thrust, having the motors this far out would mean that you're probably not going to make it back home. Use of any power at that point would probably result in uncontrolled departure from controlled flight. And when you do land, you're pretty likely to have a prop strike and break propellers, even in a normal landing. So, yeah, well, you're much more likely. Now, it's a little bit less likely if you have the landing gear, because you're further up and presumably wouldn't, you know, tip over onto the wingtip. But yeah, so they could have done better there. I really like the wingtips. Now, the full-scale airplane actually has these winglets that stick up, so that would be totally impractical for the model, and would require, for that to work at this different Reynolds numbers, that would require a lot of work, at least in CFD, computational fluid dynamics, or also in a wind tunnel to actually make those work. Not likely. This is a far better solution. I really like the wingtip. They just needed to make the wings longer and make a nacelle that's more appropriate for a model, electric powered model, rather than the just copying the scale design. The ESCs fit in these pockets. I bought some relatively cheap 30 amp ESCs. I'm going to be using some lower kV motors. I think 920 kV DJI motors for this. Also, they have these little plates that go in here, and if you notice, they seem to fit. You know, they fit very well. So you'd basically screw the motor to this from the backside, which I like, because I don't like using the X mounts. They're just, well, normally they're too big. For these motor mounts, it wouldn't be a problem, because the motor nacelle is really big. But you got to be careful, because if you turn these around, they no longer fit. So these are not completely symmetrical. There's a different step on one side than the other. So just if you get it wrong, just turn it around. So no problem there. They also have, another thing I would like to see different on this wing design and the base of the fuselage here is they take the motor wires that go to the ESC, and then they've got the power wires from the ESC, from the current sensor or battery to the ESC, and they run the servo wire from the aileron. This is where the aileron servo would go, and the flap servo would go right here. And the servos fit in very well. They nest very well in both of these spaces. But there's no other place to run the servo cables other than right next to the ESC and right along adjacent to the main power wires. So hopefully they don't pick up any noise there running past those. It's probably not an issue, but why not run them separately? There's no reason they couldn't do that. Also, there's channels here for the light kit. So thankfully, these channels are not really that deep. So if you don't use them, no problem. I do like that you do not have to permanently glue the bottom of the nacelle on. It comes with some screws and has some plywood parts, so you can just put this there, put a couple screws in it, and not only it gets air cooling, which it doesn't really need, but it the push rod comes out here for the flap. But yeah, it doesn't really need the air cooling, but you can remove it if you want to change motors or make an adjustment to the linkage of the servo, or even pull the servo out and change it. So we're using these Emacs servos. We've got some of these Emacs micro servos. Let me find. Here it is. So this is Emacs ES08MA2 analog servo. So these are metal gear, and they fit perfectly in all the places on this airplane. Now you will need 7 servos for this airplane if you're using the landing gear. So you obviously use 2 servos, one for rudder elevator, 4 for ailerons and flaps. So rudder, elevator, aileron, flap, that's 6, and then 1 for the steerable nose gear up front. And they have included several, I don't like to use these, but they have included several Y connectors for people that want to put a plug and play system together. I prefer hardwiring everything just because I'm that way, but they've included these. So the flaps obviously will be wide, the ailerons will be wide, and the rudder will Y with the nose gear. So that's great. They also include some hardware, little standoffs for mounting a flight controller. I'm not really sure how these are supposed to work, because the cutouts in the deck for the flight controller, these actually go right through them. So I'm not sure how. I would think there would be a hole there. This would sit on top. It would get a screw from the bottom, and they do provide screws. It would get a screw from the bottom to hold it on, and then you would put the flight controller on top and then put another screw in the top. And they would be tall enough that you could put screw from both sides. So I'm not really sure how that's supposed to work. Maybe someone could enlighten me as to that. So again, here's the little thumb screws that go into the ends of the wings, and they just go in like that. They work really nice. There's no binding in the threads or anything. They thread right in. Very cheap solution, but works great. Nothing more is needed. It's very lightweight. The wings are lightweight. Of course, there's the carbon spar, that 8mm carbon spar that goes into the wing. It goes pretty far into the wing, so it goes out there. And there are also 2 other carbon spars embedded in the wing that go from the leading edge spar goes from the outside of the motor nacelle, close to pretty much to almost to the wingtip, and there's another spar that goes from near the wing root all the way out near the wingtip. And those are embedded in the foam, so they were probably held in there with little clips. That's why these holes are here when they molded the foam. So that's great. Torsionally, you know, there is a little bit of flex here, but it's much stronger than most models this size. So I don't think you're going to have any structural worries with this, unless you go extending the wings and loading it up with a ton of weight and doing aerobatics. Short of that, you won't have any structural issues with this airplane, I believe. So there's the motor nacelles, the motor mounts, little screws that we looked at for holding the bottom of the motor nacelles down. And there's also, not sure where the other one went, but they did provide a couple of servo extensions for the tail servos as well. Of course, I would prefer to, I'm not going to use these because I prefer to just lengthen the wire, hardwire everything, and do it that way. There's this canopy that they provide. Now I did notice that although it looks like the edges of the canopy, if you cut it out at these edges, will fit very, very well if you were to glue it on. I believe they mean you to use these 4 little square rare earth magnets to hold it down, and there's these little pockets to glue them in, but they don't really line up. You know, if you line this one up, this one is not in the right place, and if you move it forward to line that up, this one's not in the right place. It also seems that the ones on the sides don't reach down far enough, the pockets, to go to the magnets that are on the deck. But I don't really care about this because I'm probably going to be gluing this on anyway, and so that doesn't matter. But anyway, I would love to see this a different wing for this airplane at some point. It would be great. I may even make my own, so we'll see how that goes, and see what other modifications we can come up with for this. Also, it looks like it would be possible. I've got a PT60. This is that's just the part number for these PT60. You can find these on eBay. Airspeed pitot tube, and it looks like these holes right here. I don't know if they meant to do this, but you could drill those out just a little bit. Run the screws that came with the airspeed sensor up through the bottom, and you know, it threads into the screws that come with the airspeed sensor, or the airspeed pitot tube thread into it. So that could be mounted right there, and then you just cut a couple of holes here in the canopy for the silicone pressure lines, from, you know, to go there to either analog or digital airspeed sensor. You could probably mount that to the deck here, so we'll probably do that at some point. And we'll also be using, for this build, we'll be using the new Matek F765 wingboard, and this is really brilliant because what it does, it internalizes a lot of the peripherals that we've been using on Pixhawk into the inside, whether it be well, for one, the current sensor or current sensors. It internalizes those, and allows provides power to the servo rail from the top deck. So it has a bit built-in BEC, so it eliminates the BEC, and it has an SD card just like a Pixhawk. Pretty much has all the functionality of the Pixhawk. It's an F7 processor, so should have lots of headroom for, and it can also run Ardupilot, importantly. So there's not a lot of information on that right now. We did manage to flash Ardupilot on it. Not being a computer expert, this was a little hard for me, but I did manage to do it. So we've got Ardupilot running on there. We've got a digital airspeed sensor that did not come with it. Matek does sell a analog airspeed sensor, which we ordered, but we're not sure if we're going to use that. We'll probably use this digital one. So that should make this little airplane into a much more practical autonomous mapping airplane than it otherwise could have been, and allow it to have more internal volume because you're eliminating a lot of the peripherals. Also free up weight. This is a very lightweight little controller board. So we'll probably be mounting this and doing some flights with it. And we may redesign the wings, make some new wings for it to make it into an even better platform. So thanks for watching and have a good one.